Hi friends, so we'll be dealing with multi-level returns. Okay, so what do you mean by multi-level returns? Okay, so let's consider three functions: A, B, and C. So there are three functions: A, B, and C. Okay, so inside the function A, I am calling the function B. Somewhere inside the function B, I am calling function C. And in function C, what I am writing is if there is a condition, I am writing go to level 1. Okay, so I am writing like this, go to level 1. Okay, so this is the structure. So there is a function A. Inside the function A, there is a function called to B, and there is a function B in which there is a function called to function C, and here is a C function, and the peculiarity of C function is there is a line called go to label 1. Okay, so in the main program, if I'm writing like I'm calling A, I'm calling a function called A, I'm calling a function called A, and in the next step there is a label, so, and L1, and I'm writing some steps. Okay, so there is a label L1 here. Okay, so let's see how this executes. Okay, so first what happens? First, A is a function, so to stack, I'll be just storing all the details of main function in the stack. All the details of main function in the stack. Okay. And what I'll be using the uh, I'll be calling the A function, and I'll be executing this first step of A function, second step of A function, and there is the function called B. It is called. So since another function is called, whatever the current scenario, maybe all those scenarios will be stored, all the environment will be stored in stack. So inside this there will be uh, space for all the variables inside a function. Here and here you can see, and it will start executing the B function. It will execute the first step of the B function, second step of the B function, third step of the B function. Then we can see a function called to C. So what happens, since there is a function called, the current scenario or the current environment will be stored in stack. So whatever the current scenario of B is, whatever the environment of the B is, whatever the values inside the B is, all will be stored in stack. Okay, and what happens? It will go and execute the function C. Okay, it will execute the first step, second step, and there is a if statement. If the condition is true, what happens? It will go for go to. It will go for go to, and it will go to the label one. Okay, so it will go to the label L1. Where is the label L1 is? L1 is outside all this. Okay, so L1 is actually inside the in function. Okay, is the next step after function call of A. So it is inside the main function. It is inside the main function L1. So what happens from here, from the C, that is the from the environment of C, it will have to jump directly to the main function. Okay, if this is an ordinary function call, after execution C, it will move to B, the rest part of B. Only after executing the rest part of B, it will go to A. After executing the rest part of A only, it will move to where L1, because after the function called A, there is L1. Okay, so if I'm doing the function call, if I'm doing the function call from A to B, B to C, the function will return like C to B. Okay, after executing all the steps of C, it will go to the next step of B. After executing all the steps of B, it will go to the next step of A. After executing all the steps of A, it will go back to the main function. But instead here there is a go to statement which will directly ask it to execute the later steps of main function. Okay, so this type of call is called multi-level return. This is called multi-level return. Okay, so this is called multi-level return. Okay, so instead of the ordinary return statements in which after executing C it will go back to B. From C it is directly going back to the main function. Okay, so this is called multi-level return. And you can see the program here. You can just go through this program here and you can understand the same phenomena here. Okay, so this is called multi-level return. Okay, multi-level return. So it requires the deallocation of multiple stack frames. Okay, so whatever the stack frame of B is and whatever the stack frame of A is, it contains all, it will be deallocated, and only the and also main function, it will be loaded to the memory. Whatever the current scenario of the main function, it will be loaded to memory. So the multiple level return do requires deallocation of multiple stack frames, and this process is called unbinding. The deallocation of multiple stack frames is called the unbinding. Okay, it also do the book operations of restoration of the registers. That is, the whatever the registers values for the main function will be restored. Whatever the bookkeeping information of the main function is there, it will be restored. Okay, so it do have two steps, that is unwinding and also bookkeeping operations. Unwinding means it will deallocate multiple stack frames, and bookkeeping operations means it will just restore the registers. Here it will get registers will be restored with the values of the main function. Okay, so that is all about the multi-level. And I hope you know about errors and exceptions. Like that will be a handler try catch. Try catch is an example for exception handling. Okay, try catch will be the exception for exception handling. So if I'm writing some steps in try, okay, so if it comes to an exception, what happens? If it comes to an exception, what happens? It will just directly go to the handler, and handler is here. It is catch. So the handler will tell what all you have to do if you have gone through an exception. If you are found an exception, what you have to do? It will be written in the catch. Okay, so this is how the exceptions are handled. Uh, okay, so to handle exceptions, the programmer appends a block of code called an handler to complete the expecting exception. Okay, so here the catch is the handler, and in this handler, I am just writing all the statements that I need to include if I have found a or if I have got an exception. Okay, and the handler is to provide step to recover from the exception. Okay, and if there is no exception in the try block, if I have no exceptions, then the handler, that is the catch part, will not be executed. Okay, if there is no exception found in try block, then the catch block will not be executed. the handler will not be executed. Okay, I'm just going through this very fast because I think you already know about the try catch exception handling and all. Okay, so I need not say in detail about this, so I'm just going through the topics. Okay, now this is a main flow, main thing that I want to go through, that is control flow. Okay, I already explained you what a control flow is, how the flow of control happens in a program. Okay, the flow of control happens like first one it is sequencing, second one it is selection, third one it is iteration, fourth one it is recursion, and the fifth one it is non-determinants. Okay, so we'll go to the control flow. The first one is sequencing. This is a very important question. It is very easier for you to just explain. If it is an essay, what you have to do is you have to write what is a sequencing is, give an example, what a selection is, give an example, what is an iteration is, give an example, what a recursion is, give an example, and what a non-determinant is. There is no example for non-determinants. Okay, so this is all what you have to do if you are asked to write an essay about a control flow. But when I'm lecturing, I'll be just giving out some more keywords which may be asked for a 2 mark, 3 mark questions. Okay, so you have to go through that also. That are also very important, but you may not include it if you are writing an essay for a control flow. Okay, so first one it is sequencing. Okay, so you all know what a sequencing is. Actually, a sequencing is if there are 3 steps or 4 steps. After first step, you will execute the second step. After second step, you will execute the third step. After third step, you will execute the fourth step. Okay, so this is called sequencing. Okay, and there is nothing more much to say about sequencing. You just can say that if I'm writing all this inside a begin and inside a begin and end, then I can say that this is a compound statement. Okay, and if I am writing with some declaration also, if I am including some declaration also, then I can say that this is a block. That's all. Okay, that's nothing much important. Just you have to understand. Okay, if I'm writing it inside a sequence of steps inside a begin and end, it is called a compound statement. And if I'm just including some declaration also, we can say that it is a block. Okay, that's all. And the side effect is, I have already said about this side effect, that is function change in the argument. Okay. Next one is selection. Okay. In this selection, we'll be dealing with 2 things, that is if then else statement and a switch case statement. Okay, so let's start with if then else statement. Okay. So if then else statement, what we'll be discussing is we'll be just rewriting this into a form of some assembly code. Okay, assembly level language. I will be just rewriting this, and I will be just finding out how this will get executed. That's what we'll be doing for this section. Okay, so if I are asking about a essay on control flow, you just need to give what an if statement is, what a switch case statement is, and you can just give this example. You need not write the assembly level language example if an essay is asked about control flow. Okay, but if there is a question which is asking about if then execution of if then else statement, or specific question only, you need to write about this assembly language and all. Okay, so this is a selection. So in this selection statement, what I'll be is first one is if then else statement. Okay, so this is the if then else statement. If A greater than B and C greater than D or E not equal to F, then there is something called some clause will be executed, or there is something that else clause will be executed. Yeah, so this is an example for if then else statement. Okay, so let's see how this gets evaluated. Okay, So this is a Pascal language implementation. This is not actually a Pascal language implementation. This is an assembly code which refers to the Pascal language implementation. Okay, this is actually an assembly code which refers to the Pascal language implementation, how it will be implemented in Pascal. Okay, there is no jump code. So the condition is like if A greater than B and C greater than D, or E not equal to F. I hope this is the condition. Yes, that is condition. Okay, A greater than B and C greater than D, or E not equal to F. Okay, so in Pascal, which is not using a jump code, what it will be doing is first it will store A to R1. Okay, so firstly what it do is it will store A to R1. Store A to R1. Then it will store B to R2. Okay, it will store B to R2. R2 it will store B. Okay, so R1 will have A and R2 will have B. Then it will check R1 greater than R2. It will check whether R1 greater than R2 and it will store the result in R1. So now the R1 will have a true or false result. So now the R1 will have a true or false result. Okay, then what you will be doing? C will be stored in R2, D will be stored in R3, and this result will be stored in R2. Clear? Okay, and then what you will be doing is you will be just completing this one. You will be just calculating this, or you will be just uh, doing A greater than B and C greater than D. So R1 has the result of A greater than B. R2 has the result of C greater than D. So what happens? It will just calculate R1 and R2, that is A greater than B and C greater than D, and the result is stored in R1. Clear? Then what happens? It will store E2 R2, F2 R3, and it will evaluate R2 not equal to R3, R2 not equal to R3, and the result will be stored in R2, and the result will be stored in R2. After that, what you will be doing? You will be do the OR condition, or zero. The resultant, if it is zero, that means the whole condition, the result of the whole condition is false. If the result is zero, then it will go to L2, that is the else clause. If the result is not zero, that means the condition is true, so it will go to the then clause. Clear, right? Okay, so this is how it will be used in Pascal, which doesn't have jump code. So whatever the value of the all the conditions, it will be stored in some registers, and it will be doing the serial way. Okay, hope you understand how it is getting executed faster without using a jump code. If it is in jump code, it will be using more go-to statements. It will be using more go-to statements. Okay, it will be using more go-to statements. The same thing is executed using jump code like this. Here you can see a lot of go-to statements are there. A lot of go-to statements are there. Okay, so the condition was if A greater than B and C greater than D, right? Yeah, A greater than B and C greater than D, and or E not equal to F. Okay. And using jump code, what happens is it first calculate A greater than B. So similar the way A will be stored in R1, B will be stored in R2, and it will check whether R1 greater than R2. If R1 is greater than R2, then it will go and evaluate this one. If the condition is false, then it will directly go to else clause. Sorry, else clause no, it will directly evaluate this one. If the condition is true, it will go and check for C greater than D. If the condition is false, you know that the resultant of this one will always be false. So it will go for the OR condition. Okay, so here we are checking for the OR condition. So if the result is false, that is A is not greater than B, that is A less than B, R1 less than R2, that is this condition is false. Since this condition is false, it will go to here. So it will go to L4 if the condition is false. Which condition? A greater than B, that condition is false. Okay, A greater than B means R1 greater than R2 is false. R1 greater than R2 is false means R1 less than R2 is true. So if this condition is true, that means A greater than B is false. It will go and check the E not equal to F condition. Clear? Likewise, it will go for CD. Okay, and if this is true, what happens? If this is true, if this is false, it will go for E or F, E not equal to F. If this is true, what happens? It will check C greater than D. If A greater than B is true and C greater than D is true, then it will directly go to the then clause. Okay. If this is true, then you will just go for C greater than D. So what you will be doing, you will be assigning C to R1, D to R2, and you will be just comparing it, R1 greater than R2 or not. And even if this condition is also true, that means A greater than B is true and C greater than D is true. If so, it will directly go to the then clause. It will directly go to the then clause. And if this condition is false, again, similarly, it will go to E not equal to F condition. Okay. If E not equal to F condition is false, it will go to the else clause. If this is true, it will go to the then clause. Clear? So here there are a lot of go-to statements, and the number of steps that we will be using and number of registers that we will be using for this jump code will be small. Less number of registers will be using. Okay, so this is how the selection will be executed using jump code. So selection, there are two parts. The first one is which is not using jump code. Okay, that means it will be using a lesser go-to statements. Go-to statements will be used only at the end. Okay, actually, when we are saying that, you can say that the label is not actually used is written here. That means there is no go-to statements. But to make you understand, it is right. One go-to statement is only in jump code. There is some go-to statements we can write. Okay, so and this will be full of go-to statements, and you can understand that it will be easier to evaluate, easier to write a code. I hope it is clear. Okay, so that's all about selection. If then, now there is something called switch case. Okay, so switch case, you know that switch case. So here there is a statement for if then statement, and the corresponding switch case statement is written here. Okay, so if I equal to 1, then close A. So case 1, close A. If I in 2 comma 7, that is if I is 2 or if I is 7, then close B. So 2 comma 7, close B. If I in 3 to 5, this is 3 to 5, that is I can be from 3 or 4 or 5. The value of I is in between 3 and 5. close C. So 3 to 5, close C. Else if I equal to 10, the value of I is 10, then close D. If all these are false, that is else, close E. That is else, close E. So this is an equivalency of this if-then statement and case statement. Okay, so the equivalent case statement of if-then statement is like this. Case 1, close A, 2 comma 7, close B, 3 to 5, close C, 10, close D, else, close E. Clear. So this is an example. Now we will see how it is getting evaluated. Okay. So here is the evaluation and using the jump code statement. Okay, as a jump code statement, the evaluation is here. You can just see the evaluation here. Jump code statement evaluation is here. Selection. Okay, the jump code statement evaluation is here. You can just go through it. It is similar to the previous one. Now, since this is a case statement, okay, since this is a case statement, you can. It's a more similar way is to use a jump table. Since this is a switch case statement, the most similar way to execute this is using a jump table. Okay, so here there is a table called T. There is a table called T. T is a table. Okay, T is a table, and actually it will be in the form of array. So here we can say that there is first element is address of L1. Address of L1 means here the code for L1 will do contain some code, and the address of that code is here. Likewise, L2 do contains some code, and the address of that code will be stored here. Okay, L3 we have some code, and the address of that code will be executed here. 3, 3. Clear. And L5, L2 likewise, L5, 4. Okay, so actually jump table to contain a set of addresses, and these addresses will be pointing to some code. Okay, now let's see which code, which one. Okay, the first code. Okay, the first code. Okay, listen here. Okay, so there is something called a close A, right? For one, you can see that for one. Okay, so if the case is 1, you will be executing close A, right? So what happens is here close A, that is whatever that is executed, whatever that need to be executed if the value of the switching is 1, switching variable is 1, will be close A, right? And the address of this close A will be stored in L1. Address of this close A will be stored in L1. Clear? Okay. L2 will correspond to close B. That is, close B is 2. Okay, 2 to 7, 2 or 7. If the value is 2 or 7, we will be executing close B. Clear? Okay. And here you can see L3. So L3 corresponds to close C. Okay, L3 corresponds to close C. So this will correspond to close C. This will correspond to close C. Now there is something called L4. L4 is there, and L5. Okay, so here there is 10, and there is an else statement. Okay, let it be the just will I will explain how this will get executed. How this will get executed. Okay. So first, just I am writing like R1. Okay, so R1 is a register, and I am assigning the value of the value to be copied or the value to be checked to R1. Okay, that is the switching element. Whichever the switching element is, the value of the switching element is copied to R1. Okay, the value of the switching element is, so the value of switching element. The value of the switching element is copied to R1. So R1 has the value of the switching element. Clear? Okay. Now look, R1 do have the value of the switching element. And this is T. So this is a table. So the table have the indices 0, 1, 2, 3, 4, 5, 6, 7, 8. The table will have the indices 0 to 8. Right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry. 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there are indices from 0 to 9. So this will be for 0, this will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so first it will check whether R1 is lesser than 1. Okay, if R1 is lesser than 1. If R1 is lesser than 1, what happens is go to L5. Okay, lesser than 1. Lesser than 1. So here there is no lesser than 1. Okay, so this is cases 1, 2, 7, 3, 5, 10. Okay, so if it is lesser than 1, there is else, right? Else clause. It will go to the else clause. So L5 corresponds to else clause. So L5 corresponds to else clause. L5 corresponds to else clause. L5 corresponds to else clause. That is clause E. L5 corresponds to clause E. Okay, so if R1 less than 1, it will go to L5, that is clause E. So the else condition will be executed, right? Okay, if if it is lesser than 1, it will go to clause E. It will go for the else condition. Okay, likewise, if the value is greater than 10, then also it will go to else condition. If the value is greater than 10 also, it will go to else condition. That is what it is written as. If R1 greater than 10, it will go to L5. L5 we have clause E. Okay, if these two are not satisfied, then I am writing R1 minus equal to 1. That is R1 equal to R1 minus 1. So if the value of R1 is 1, if the value of R1 is 1, R1 minus 1 is 0. So the value of R1 will become 0. R1 will become 0. The value of R1 will become 0. If the value of R1 is 1, it will become 0. Okay. And here it is written as R2 equal to T of 0. T of R1, now the R1 is 0. T of 0 is L1. That is, here the L1 will be executed. What is L1? It is clause A. Clause A corresponds to 1. Okay, here you can see if the value of R1 is 1, clause A is executed. The value is 1, clause A is executed. Okay, so here if the value of R1 was 1, it is decremented to 0 and T of 0 is called. T of 0 corresponds to clause A. Likewise, so what happens is for each value from 1 to 9, that is or for all the 10 values, it is just giving an address to be executed, address of the code to be executed. Okay, that is, if the value to be checked is 1, it will be decremented to 0, and it will correspond to the value to be executed is L1. If the value is 2, then it will be decremented to 1, and the value that need to be executed for R1 is 2 is stored in L2. The address is stored in L2. Address of the code is stored in L2. Likewise, if the value is 3, it is decremented to 2, and the value and the code that need to be executed is stored in L3. Okay, if the value is 4, it is decremented to 3. Okay, you can see that from 3 to 5, you need to execute the same code, L3. Here you can see that 3 to 5, you need to execute close C. 3 to 5, you need to execute close C. Okay, so for 1, you will be executing close A. 2 and 7, you will be using close B. Okay, so you can see that here. Sorry. Okay, so you can see that for 2, it is L2, and also you can see that if it is 7, it corresponds to 6, then also it is L2. For 2 and 7, it is L2. Okay, if it is 3 to 5, it is L3. Whatever the code it is stored, it will be stored in L3. 3 to 5. Okay, and for 6, there is no code. You can see that for case 6, there is no code. So it will go to the else part. Else part is L5. Else part is L5. So for 6, it will go for L5. For 8, it will go to L5. For 9, it will go to L5. And for 10, you can see that here, for 10, it will go to the close B. So L4 responds to close D. L4 responds to close D. Okay, so here you are just using a table, and table you are storing the address of the uh, program code that you need to be executed. Clear? Okay, so R2 equal to T of R1. So R2 will be having the address of the code to be executed, and you are writing go to star R2. So if I am writing go to star R2, the corresponding code will be executed. Clear? So this is how the case statements will be executed based on jump table. So this is a very important question, jump table. How case switch case is implemented using jump table is very much important. Okay, you have to go through it. Next one is iteration. What do you mean by iteration? Okay, so iteration means you know that for I equal to whatever something that you need to be repeated comes for iteration. Okay, so I can say that for I equal to last step by step to do and so this comes for iteration. Okay, iteration can be done in two types. Can be implemented in two types. In first type, what you will be doing is you will be taking R1 as the first, R2 as the step, R3 as the last. Okay, so first you will be checking whether first is lesser than R1. First you will be checking whether first is lesser than last. Okay, if it is greater than last, then it will stop execution by moving to L2. If it is greater than last, first is greater than last. If it is not greater than last, that is, if it is within the bound, what happens is whatever the body inside the loop, it will be executed, and after the execution, it will increment with the step. That is R2 is the step. Okay, so if I am writing for loop like this, for I equal to 0, I less than 5, I plus plus. It's so first is 0, first corresponds to 0, last step corresponds to 1. It is incremented by 1 in each loop. Okay, and that last corresponds to 4. Clear? So this will be how it will be just calculating. Okay, and this is another method of calculating or executing this for loop. In this, what happens is it will just calculate how many times the loop will execute. How many times the loop will execute. Okay, it will just check whether how many. I'm sorry, it's not so. This is an entry control. Okay, and in this you are using two go to statements. In this you are using two go to statements. Sorry. This is a control in which we will be just implementing two go to statements. Okay, but in this type of implementation, what you will be using is in the repeating part. Here we can see that this is the repeating part. Okay, inside L1, L1 is the repeating part. In L1, there will be two go to statement. But here you can see that the repeating part is this one. This one is the repeating part. L1, L2 is the repeating part, and you can see that there is only one go to statement in this. In the repeating part, there is only one go to statement. Okay, so this is two implementation of uh, for loop, or you can say that iterative loop. The first implementation, you can see that in the repeating part there is two go to statements. Okay, the second one, you can see that the repeating part. Actually, in the full program there are two go to statements, but the one in the terms of repeating part, this is the repeating part. Okay, this will be repeating, and inside that there will be only one go to statement, and this will be less complex compared to the first one. Clear? So this is two implementation of the go to. Clear? Okay, and there is something called a combination loop. Okay, combination loop is specifically refers to a for loop combination loop, in which the initialization, condition, and the updation is done in a single step. Okay, so this is called a combination loop. Okay, so combination loop, what do we say that? Combination loop is, you know, for loop is an example for a combination loop in which the initialization, condition, and application is done in single step. Is brought together to just improve the understandability of the program. Okay, so this is called a combination. Okay, now you need to call something as an iterator. Iterator is a very important question for programming. So iterator, what do you mean by an iterator? Okay, so actually what we do is in C program and all, what we will be doing is we will be just repeating some part of loop, right? We will be just repeating some part of loop. We will be repeating using the go to statement. The implementation is like you will be using the go to statement. In iterator, actually what you will be doing is you will be using a list. You will be using a list. Okay, so in iterator you will be using a list, and if the condition is okay, so if this is from for I in range from first, let the first equal to 0, last equal to 5, and the step equal to 1. Okay, so for I in range 0, 5, 1. Okay, so 0 to 5, the step is 1. What happens is if the compiler comes across this, what it does is it will store all the values that can be used for I in a list. Okay, so I can have the value 0, I can have the value 1, I can have the value 2, I can have the value 3, I can have the value 4, I can have the value 5. So all those values are stored in a list. All those values are stored in a list. And what it does is it will just fetch the values. For the first loop of execution, first execution, it doesn't have any condition. It won't check for a condition. It will take the first value 0 for I and it will get execute. It will execute. Okay. Then it will take the next value 1 for I and it will execute the body. Then it will take 2 for I and it will execute the body. It will take 3 for I and it will execute the body. It will take 4 for 5, 4 for I and it will execute the body. And will take 5 for I and it will execute the body. Since the list is empty, it will stop. It doesn't check whether the first list down gate or first less than last or something else. It will store all the values that can be assigned to I in a list and it will take the values one by one. Clear? That is how iterators work. That is how iterators work. And the example for iterator is for in Python. For in Python is an example for an iterator which stores all the possible values of the iteration variable into a list and it will fetch the values from the list until the list is empty. And this is how this will get executed. Clear? So that is called a iterator. Now you can see that there are some logic. We can say that iteration is of three types. Okay, iterations come for logically controlled two. Okay, logically controlled loops. Logically controlled loops, we can say that logically controlled loops are of three types. The first one is pre-test loop. Pre-test loop is in something which test before entry. It is called the pre-test loop. The example is while and for. Logically controlled loop. Another example is post-test loop. The example is do while. Okay, and there is something called a new one which is called the mid-test loop, in which the test is done in the middle, that is inside the functional body. You can see that here. Here is the test. Okay, it's inside the functional body. Somewhere inside the functional body, the test is taken. So it is called the mid-test loop. You can just go through this statement, and if you have any doubts, you can just clear it. Okay. So that's all about the iteration. Now we move to the recursion. What do you mean by recursion? The function calling itself is called a recursion. You can see that this is a example for recursion. Okay, so recursion. The function calling itself is called a recursion. Okay, so this is an example, and also you know that factorial is an example. Factorial. Okay, factorial is a common example that you will be dealing with. A and you will be writing return a into f of a minus 1, right? F a into f of a minus 1. And if a equal to 1 or 0, you will be returning 1. Okay, if a equal to 1 or 0, you will be returning 1, else you will be returning a into f of a minus 1. So this is an example for recursion, and this is another example for recursion. Okay, and in recursion, there is something called a tail recursion, which is very important question. Okay, so in iteration, iterator is an important question, and in recursion, tail recursion is an example. It's an important question. So what do you mean by tail recursion? Tail recursion, you know that. Okay, in normal recursion, what happens is actually you know that for factorial of a. Okay, so factorial of a is a function. It's a recursive function, you know that. Okay, now you can see the code here. Factorial of a. Okay, so what it does is, okay, what it does is, I'll just give an example. If I'm taking 5 as a factorial of 5. What is the factorial of 5? I will just move to 5 into factorial of minus 1, that is factorial of 4. Factorial of 4 is 4 into factorial of 3. Factorial of 3 is 3 into factorial of 2. Factorial of 2 is 2 into factorial of 1. Factorial of 1 is 1. Okay, so What you do is you just calculate like 5 into f of 4, 5 into 4 into f of 3, 3 into f of 2, 2 into f of 1, and you got that 1 as the result of f of 1. So what you will be doing? You will be just recalculating. So what you will be doing? You will be multiplying 1 into 2. Okay. After that, you will be calculating the result with 2 into 3, that is 6. And that result is 3 into 4, that is 6 into 4, that is 24. Then 24 into 5, that is 120, and the 120 result is returned. This is how the factorial recursive function factorial works. Here there is a flow to the subgroup, and there is a return. Okay, two-way procedure is there. Okay, in some of the factorial function, you need not have this return. Okay, you need not have this return. For example, look at this. This is a GCD. Okay, so this is a function for find the GCD. Okay, or for simple value, I'll be just giving that you know that something called a between C series. We know that. Okay. Anyway, let's go for this GCD. In this GCD, what you will be doing is, okay, uh, here first what you will be doing is, if you need to find out the GCD is the greatest common divisor, That is, if 25 and 15, okay, 25, 50, and 15 are the two values, then the greatest common divisor is 5. Greatest common divisor is 5. 5 is the divisor of both of this, and 5 is the divisor of both of this, and it is the greatest one. So the result is 5. Okay, so how this will be calculating is to find the GCD of 25, 15. Okay, GCD of 25, 15. You will find what? You will find GCD of, since 25 is greater than 15, you will be finding the GCD of 25 minus 15. That is, you will be finding 10, 15. Clear? GCD of 10, 15. Okay. To find the GCD of 10, 15, what you will be doing? Since 15 is greater, it is similar to GCD of 10, 5. That is 15 minus 10, that is 5. To find GCD of 10, 5, what you will be using is, you will be using GCD of 10. 10 is greater. Okay, so 10 minus 5, that is 5. 5, 5. GCD of 5 is 5, 5 is, you know that if A equal to B, return A. So the result will be 5. So you got the result here, and you need not tail back. You need not go back to the function to find out the result. But here you know the value of f of 1 as 1. But to find out the value of factorial of 5, you have to recalculate 1 into 2, 2 into 3, 1 into 2 into 3, all that into 4, all that into 5, all that. We have to recalculate. Okay, you have to go to the function which called it, and you have to calculate the value. But in this, you know that there is only one word flow. After one word flow, you got the result. Okay, this is a recursive function, but you need not recalculate or go back. Okay, you need not go back. That is actually the usage of stack. You need not use the stack for this. Why? Stack is used only if I am having a function A, B, C in stack. Why stack is used? Because after execution of C, I need to go back to B. After execution of B, I need to go back to A. For that, I am using a stack. For this one, I need a stack because after calling f of 1, I need to go back to what called f of 1, that is f of 2. I need to go back to f of 2. Okay, but here in this, there is no going back. There is only one word movement. There is no going back. So what happens? I don't need a stack. Okay, you can use the same value. Okay, same value for A and B. A and B can be overwritten. You need not store the instinct of A and B into the stack. Okay, so this type of recursion in which there is only one way of motion is called what? Tail recursion. It's a function which additional computation never follows a recursive call. Okay, the return is simply what function returns. Here the function returns is 5. It need not go back. Whatever the function returns, it will be the return value. Okay, and the computer or the compiler need not spare a stack to store the old values. Need not use a stack for storing the old values because it is not using the old values. It is not going back. It is not using the old values. Okay, so this type of recursion is called a tail recursion, which doesn't go back. Clear? So that is the tail recursion. And there are two types of evaluation. The first one is applicative evaluation. Okay, if there is a function and I am writing it a as 2 plus 3. Okay, there are two possibilities. Either I can pass a of 5. 5 is the resultant of evaluation of this expression. 2 plus 3. It is evaluated and the result is 5 and it can be passed. That is one possibility. The other possibility is I can just pass it like this itself. So if I am passing like this itself, only if I need to just print the result or I need to write a, okay, if I need to only when I need to use this, then only the result will be calculated. Only then the result will be calculated. Until then, it will be stored as 2 plus 3. The result will not be calculated. Okay. So the first one in which the result is calculated at once and it is passed to a function is called applicative order. The second one in which the result is not calculated but the expression is passed through the function. The expression itself is passed through the function. Is called the normal order. In this the expression is passed and the argument is evaluated only when it is required. Only when it is required, it is evaluated. But in application order, the argument is evaluated and then it is passed. Clear? That is the difference between application and normal order evaluation. And there is something called a lazy evaluation. Okay. Okay, so this is an example. Here we are saying about the lazy evaluation. Okay, lazy evaluation. Lazy evaluation. Okay, actually lazy evaluation is a type of normal order evaluation in which the value will be stored or the expression will be evaluated. The expression will be evaluated only if it is required. That is a normal order evaluation. Okay, so lazy evaluation is a type of normal order evaluation. The advantage of lazy evaluation is that if you are just storing some value, so if you are just evaluating a value, that is, if you have evaluated 2 plus 3, if you have evaluated 2 plus 3, then you will be storing the result in a table. Okay, if you are evaluating a value 2 plus 3, then you will be storing that result into a table. And whenever, in which all places this 2 plus 3 comes, in many places of the code there will be 2 plus 3. So instead of calculating 2 plus 3, it will be taking the result from the table. So the calculation complexity can be reduced. The time complexity to calculate can be reduced because the result is already stored in the table. So what happens is instead of calculating 2 plus 3 anymore, it will be just using the result 2 plus 3 which is stored in the table. So that is a that is some advantage of a lazy evaluation. And the delay, okay, and the process of storing the data, the process of storing the value of the evaluated expression. The process of storing of the value of the evaluated expression is called memoization. Memoization. It is not memorization. It is memoization. It's memoization. Storing the result of the expression in a table so that it can be reused. Okay, it can be reused. Okay, and there are two keywords. There are two keywords: delay and force. Delay means you can just delay the uh, expression evaluation. Force means can you just make the expression to be evaluated now. Force means you'll be evaluating the expression now. Delay means you'll be delaying the expression. When you are forcing the expression, the expression will be evaluated and the value will be stored in the table. Clear. So these are two keywords that is used for basic evaluation. The last one is non-determinacy and non-determinacy. So the last one of the control flow is the non-determinacy. And in non-determinacy, what happens is actually the choice of the alternatives is unspecified. How to execute which one is the next for the execution is undetermined, unspecified. It is not specified. It is basically used for the concurrent languages. Okay, it is basically used in concurrent languages. So we have already discussed about all the control flow sequences. Okay, already we have discussed everything about the control flow sequence. First one is sequencing, second one is the selection, third one is iteration, fourth one is recursion, and the fifth one is non-determinacy. Okay, hope you understood, and all these portions will be there for the materials. Okay, so that's all, and thank you.